Hey guys, Mr. Milton here. Today we're going to look at writing function rules notes. At the end of this video, you should be able to identify the pattern to get from the domain to the range. And you should be able to write a function rule from a table or situation. Okay, in this lesson, we're going to work backwards from what we've done so far. Instead of giving you the function rule and having you create a table or find the range, etc., you're going to make or write, just say that, the function rule. Okay. In the following tables, identify the pattern that gets you from the domain to the range. Okay, again, at this point, we should know from the x value to the y value. Okay, and so that should be our question each time. Does this get me from x value to y value? Does this get me from input to output? Does this get me from domain to range? Okay, and so the difference there is that you should not be saying I plus 2 every time. Every time I add 2, I add 2, I add 2, because this doesn't take me from domain to range. Instead, this takes me from one y to the next, which is not how we write a function rule. We will write a function rule by saying what goes from 0 to 3, what goes from 2 to 5, how do I get from 4 to 7, how do I get from 6 to 9. Okay, so we're always saying how do I get from x to y. Okay, so our pattern here is we add 3. From here, how do I get from 0 to 3? How do I get from 2 to 5? How do I get from 4 to 7? How do I get from 6 to 9? And that, whatever I say, so I'm looking at 0, 3. First thing that I'm thinking is I add 3. Does that work for my next value? 2 plus 3 gives me 5. Does that work for my next value? 4 plus 3 gives me 7. Does that work? It does. My value is add 3, or you can say add 3. Really doesn't matter here. This is really more of a thought process here. Our function rule, though, says f of x is we get to y by basically adding 3 to x. This is our function rule for this table. Okay. Now, for number 2, let's look at that same thought process. Remember, we're not saying, oh, we minus 4 every time, because that's a pattern of the y's. It's not telling us what our function rule is going to be. The pattern that we're looking for is what happens from x to y. So here I could say, oh, well, I just add 0 each time. Does that work the next time? No, it doesn't. Okay. So now I need to find a different way to get from x to y. And I might think that, getting from 0 to 0, I can do that 1,000 different ways. Let me see what happens next. How do I get from 1 to negative 4? I know it's not subtracting 5 because adding 0 worked this time. So let's look at multiplication. Maybe I multiply by negative 4 here. That works. Multiply by negative 4. That works. Negative 3 to positive 12. Multiply by negative 4. That works. Does it work here? Negative 4 times 0 is 0. That works. So here I say, okay, I multiply negative 4. Yes. To get to y equals negative 4 times x. That's my function rule. Number 3. As I look at this value, okay, from negative 2 to negative 7, maybe I subtract 5. From 4 to negative 1, maybe I subtract 5. Subtract 5, subtract 5. Hey, it worked. Minus 5. So my function rule, to get to f of x, I will subtract 5 from x. Number 4 is tricky. Let's see. To get from 0 to 15, I add 15. Okay, maybe. To get from 5 to 10, I add 5. Okay, so not the same. Can't do that one. Okay. Now, as I'm looking at it, like multiplying by 2 doesn't work, dividing by 2, it's all different. So now as I look at these two, I'm like, okay, what is happening each time? And so you have to kind of maybe think a little bit differently each time. But when I look at this, I'm like 0 plus 15. Well, that's 15. 5 plus 15, or 5 plus 10 is 15. 10 plus 5 is 15. 14 plus 1 is 15. Hey, all these add up to 15. How can I make that a function? How can I make that into a function rule? I know that the sum of all of these is 15. How can I make that a function rule? So I might say, okay, x plus f of x equals 15. Okay, and that's not a function rule because we really want our f of x to be by itself. Now I can just do that. I can manipulate this formula or equation and say, okay, let me just do that. Let me just subtract x from both sides. F of x equals 15 minus x. Okay, does that work? Yeah. So if I plug that in, if I plug it in for this one, 1 equals 15 minus 14. It works for this one. 5 equals 15 minus 10. 10 equals 15 minus 5. 15 equals 15 minus 0. And so finding that pattern really did help us to find out how to write this equation, even though it wasn't as simple as the first three. Okay, so make sure you're looking at that thought process and trying to be creative with that. Okay, in problem number 4, what is f of 20? Okay, so here's problem number 4, and we can answer this question pretty simply now that we have our function rule, and this is the point of function rules. Well, f of 20 is when I plug 20 in for x. So 15 minus 20 is negative 5. F of 20, negative 5. I should write the whole sentence out. F of 20 equals negative 5. Okay. What is the value of x when f of x equals 3? Okay. And I'm going to say that is still problem 4 here. So let's see. If f of x is 3, and that's here, then we plug the same rule in, 15 minus x, and now we just solve. So I'm going to subtract 15 from both sides, get negative 12 equals negative x, and so divide by negative 1, I find that x is 12. Okay, and so kind of a throwback to our first couple chapters of just solving. Skipped a lot. All right, here we go. All right, so now we're writing function rules from a situation because we did it from a table. Now let's do it from a situation. It says a cup of frozen yogurt at Yo-Yo costs 49 cents per ounce. Write a function rule to determine the final cost, CMN, of buying n ounces of frozen yogurt. So here we go. All they're asking is like, hey, write this as an equation. So I can say the cost per ounce is 49 cents per ounce. So I can say 0.49, and since n is already the established variable, 49 cents times the number of ounces that we have. How much would a cup that weighs 8 ounces cost? Well, great question. We can use our function rule now to answer that question. We'll say cost of 8 ounces equals 0.49 times 8. Using my calculator, 0.49 times 8 gives us $3.92. So I'll say the cost of 8 ounces is $3.92. How many ounces could you buy with $6? So notice here that the $6 is our total cost. So I'm going to plug in the 6 for my cost, and the rest of the function stays static for right now, and we solve it. So 6 divided by 0.49 give us 12.24 ounces. And so I'll say n equals 12 point. I don't have any directions towards rounding it. So 0.24 ounces. Okay, putting ice cream on a scale. I'm sure there are ways for them to measure half in partial ounces, so it makes sense as the answer. To rent a hot air balloon, it costs $200 plus $21 per hour. Write a function rule to determine the final cost C of H of renting a hot air balloon for H hours. So here you go. The cost of renting a hot air balloon for H hours equals $200 already plus $21 per H, because H is our variable. That's the thing that changes. How much would it cost to rent a hot air balloon for 6 hours? Well, the cost for 6 hours would be 200 plus 21 times 6, 126 plus 21, 326. And so $326. The cost for 6 hours would be $326. How many hours could you rent a hot air balloon for if you had $400? So now our total cost is 400. And we just have the same function, 21H. So to solve for H, we subtract 200 from both sides. Divide by 21. It's going to be less than 10. Divide by 21. 9.5 hours. So 9.5 hours, and I'm going to say that it's just 9 hours. You could do 9 hours. That makes sense. I don't think they're charging you by the minute after that. So probably 9 hours. Here's your math answer. Here's your real world answer. Okay. Number 3 says write a function rule to determine the change you would get from a $20 bill when purchasing items that cost $1.25 each. Okay. So I'm going to say change per number of items, and I don't like to use I, so I'm going to use T. Okay. And so what that's going to be is going to be 20 minus 1.25 per item T. So how much change would you receive if you purchased 5 items? Well, CT, I'd receive, no, it's not going to be CT because I know that that T is 5. 5 items. So 20 minus 1.25 times 5, and that gives me $6 when I multiply it. So $6.25 when I multiply it. And so minus 6.25, and that gives me $13.75. So the change I would receive after buying $5.25 items would be $13.75. Can you purchase 17 items with a $20 bill? So as we look at this, we'll say, okay, C of 17 equals 20 minus 1.25 times 17. And so our function rule, so we do this, 1.25 times 17 gives me 21.25. All right, so here's an issue, because I'm going to get 20 minus 21.25. And when I get that, I get negative 1.25. So C of 17 equals negative 1.25. Now, here's the issue. Even though we got the answer of negative 1.25, this answer doesn't make sense. That means we owe the store or wherever we purchased this from $1.25. They're not going to let us take that, right? So the answer is no. The function is negative. Okay, and sometimes it's okay to have a negative function. In this case, it's not, because that means we don't have enough money. All right, so there we go. Using function rules, whether we're given a table or given a situation. All right, and that's our chapter. Look at us. We got through it. Okay, so I'll see you, and I'll see you.